Your Majesty, esteemed laureate, Your Excellencies, ladies and gentlemen, welcome to the Abel Prize ceremony at the University Hall. We've heard the beautiful music of Per Gynts Suite No. 1, Morgenstemning, Morning Mood, by the Norwegian composer Edvard Grieg. And here we are surrounded by unique paintings by Edvard Munch, especially the monumental work, The Sun, rising in brightness and anchoring the theme of the University Hall, enlightenment. Today, we will honor the 2023 Abel laureate Luis Caffarelli and his extraordinary scientific work in the fields of mathematics. The Abel Prize is managed by the Norwegian Academy of Science and Letters and was established by the Norwegian government in 2002. Please welcome the President of the Norwegian Academy of Science and Letters, Lise Ovreaas. Lise, Abel was the genius who solved the mystery of the fifth-degree equation. But why do we need an Abel Prize? Well, what was the original intention of the Abel Prize?
Well, the Abel Prize is one of the most prestigious prizes in mathematics, and it's named after the most famous Norwegian mathematician, Niels Henrik Abel. And it recognizes pioneering and groundbreaking scientific achievements in mathematics. And the Norwegian Academy of Science and Letters are also focusing on supporting science and showing what science can do for society at large. The prize should also help to boost the society's interest for mathematics.
We know that mathematics is important in many fields, but now I will ask you, why do we need this prize today?
Well, Abel laid the foundation for several technological breakthroughs, among those the internet. And today's society needs mathematicians, and we need mathematical knowledge. It's absolutely necessary in order to deal with infrastructure, buildings, communication systems, banking, insurance, and the internet.
Can you tell us what makes this prize unique?
One important part of the Abel Prize is also to stimulate the children and the young generation to become interested in mathematics. The young children need good role models, and therefore I'm very happy that we are gathered today to celebrate Luis Caffarelli. Caffarelli has, through his work, been very supporting in stimulating the young generation and the upcoming youth generation of mathematicians. And he has been building up a large research group, supervised and mentored a whole group of PhD students and the young postdocs.
Okay, thank you, Lisa, so far. Speaking of young people, now it's a pleasure for me to introduce the young talent Birgitta Elisa Oftestad, as we heard in the opening. She made her debut at the age of 5 and is awarded several national and international prizes as a young, outstanding musician. Here they are. Many thanks to Birgitta Elisa Oftestad and Oscar Abel Valand Halvorsen. Well, on behalf of the Norwegian government, the Abel Prize is awarded by the Norwegian Academy of Science and Letters based on a recommendation from the Abel Committee. And this committee consists of prominent researchers in the field of mathematics. Please welcome the chair of the Abel Committee, Helge Holden. Helge, it has been quite a year for Argentina. First they won the World Cup last summer, and now Luis Caffarelli wins the Abel Prize.
It can't get much better, can it?
No.
Luis Caffarelli is the first Abel laureate from Latin America. He was born and raised in... He was born and raised in Buenos Aires and holds a PhD from Buenos Aires as well. And then he moved to the US.
Right. What he does is beautiful, important, but I believe it's quite complicated. So how can you, in few words, explain his work?
I'd love to explain it in a few words, but I find that very hard.
Okay.
However, I will give a better answer in a couple of minutes.
Okay, but I wonder, in your experience, what drives a mathematician on that level?
I think deep down it's curiosity. If you study an equation that, for instance, describes a natural phenomenon, it could be the flow of water, you expect a certain behavior, but can you prove it mathematically that is always so? Then you start working on a problem, and Luis Caffarelli is a problem solver second to none. In the beginning, it looks impossible. Then slowly understand a little bit more, and if you're persistent, clever, and lucky, you may find a solution at some point.
But that must be a fantastic feeling. But then what, when the last problem is solved?
It is a fantastic feeling, and fortunately, this feeling is shared also by us mathematicians who are not on the level of Luis Caffarelli. And the fortunate thing is that when you solve a problem, there are 10 new open problems that are not solved. So we never run out of problems, and the last computation is never done.
Oh, of course. Okay, I love that. But what about this year's laureate? How will you describe Luis Caffarelli?
He has a fantastic geometric intuition, and combined with a big analytical toolbox, he has the means to solve problems that people could not solve. And when he comes up with his solution, his colleagues are surprised. They ask, where did it come from? Where did you find this idea? How did you do it?
Where did it all come from?
Exactly.
That's the question. Okay. Helge, later you will explain the decision of the Abel Committee. But first, we will get to know Luis Caffarelli a little bit more. Let's have a look at this.
He's a magician. He's very much thinking outside of the box. So you get always ideas from an angle that you didn't know about. Hi Luis,
Hey,
how are you doing?
Nice to
Hard
see
at work.
you.
Do you know if there are recent results on that, or partial differential equations used in all mechanics, in fluids, in propagation of light? It's a very useful tool.
From relatively young age, I started to realize the interaction between mathematics and other areas of science and how they are interacting with each other. That makes you feel that what you are doing is beautiful and important. This is the University of Chicago.
Yes, this is you. You are such an approachable and humble person. Your personality, style, and your work style, the way how you interact with your students and with visitors and postdocs, just really very naturally creates this environment where people just interact very in a very uncomplicated, very creative way.
Hey, how are you? Hola.
He has attracted some of the best students in the world to educate here, and many of whom have gone on to have very successful careers.
The teaching, right, is connected with my mathematical creating, right? So it is very, very good because they also bring me many ideas. I mean, they learn, but also I have learned. Nice day, right? Voila! Hey, all the friends here, let's go! Working in mathematics developed into a friendship, so that's very good for science, I think. If I look you at the list of things, of my articles, I would say that the majority is collaboration. So interaction a lot for the science also brings interacting a lot for being happy. Oh, she is a wonderful being, right, in every sense.
We started dating in early '83 and we got married in September '83, so it's 40 years. We talk a lot, we watch movies. I like to see
movies,
It's very nice to watch.
I don't hit everything, but I hit 70%.
Okay, wow. Luis is a good dancer. Yeah, we actually enjoyed dancing very much. Luis is extremely creative, and quoting Louis Nierenberg, he said many years ago that Luis' ideas come from thin air. It's like you need very little to really grasp something very profound. He could do that, and I think that is what I always admire.
Until we don't completely understand it, the science is delicate. You know, it is great when it is clear and you see that has a very impact. In the meantime, it's something to work with.
Your Majesty, Abel Laureate, ladies and gentlemen, humans have tried to understand and predict physical nature since time immemorial. The ability to predict how and where water flows, how materials deform under pressure, and how ice melts to water has always been of vital importance to us. Since the days of Newton and Leibniz, we have had the language of differential equations to model this behavior. However, as we very well know, nature is often unpredictable and hard to comprehend, and so are mathematical equations. Thus, it comes as little surprise that many of the key mathematical problems remain unresolved. Mathematicians like to ask fundamental questions. Do these differential equations have a solution at all? If not, they may have to be amended. Is there more than one solution? If so, how are we to tell which one is the right one? For example, we do not want to find ourselves in a situation where the weather forecast says that the temperature tomorrow will be 5 or 25 degrees, but we are unable to determine which one it actually will be. We also need stability of solutions. A small increase in the number of people in this room will not increase its temperature by much. And mathematicians would like to confirm that these equations satisfy this. Furthermore, if we are to compute the solution, we need to know how wild or irregular the solution can be. Just as the methods to compute the surface of an ocean will be different if you encounter calm waters or a storm. This year's Abel Laureate, Luis Caffarelli, has worked on such problems throughout a career spanning more than 4 decades. Growing up and completing his PhD in Buenos Aires in Argentina, he has spent his entire career in the US. A large part of Caffarelli's work concerns so-called free boundary problems. Consider, for instance, the problem of ice melting into water. Here, the free boundary is the interface between water and ice. It is part of the unknown that is to be determined. How does surface change under melting? Another example is provided by water seeping through a porous medium. Again, the interface between the saturated and the unsaturated part of the medium is to be understood. What does a surface of water look like? A particular class of free boundary problems are denoted obstacle problems. An example is given by a balloon pressing against the wall or an elastic body resting on a surface. Caffarelli has given penetrating solutions to these problems with applications to solid-liquid interfaces, jet and cavitational flows, and gas and liquid flows in porous medium. Mathematics is a little bit like a Swiss Army knife. The same tool can be used for many different purposes. Thus, Caffarelli's results on free boundary problems have also been used to analyze problems in mathematical finance. The incompressible Navier-Stokes equations model fluid flow, such as the flow of water. The existence of solution of these equations in 3 dimensions is widely acknowledged as one of the most important open problems in mathematics. In 1983, Caffarelli, together with Kohn and Nienberg, the 2015 Abel laureate, showed that sets of singularities of suitable weak solutions are short-lived and cannot contain a curve. Thus, they must be very small. This is still the best result to date. Caffarelli's regularity results from the 1990s represented a major breakthrough in our understanding of the Monch-Ampere equation, a highly nonlinear, quintessential partial differential equation that, for instance, is used to construct surfaces of precise Gaussian curvature. Caffarelli's theorems have radically changed our understanding of classes of nonlinear partial differential equations, with wide applications. The results go to the core of the matter. The techniques show at the same time virtuosity and simplicity and cover many different areas of mathematics and its applications. But I have to warn all of you that when I use the word simplicity, it's not the same as easy to understand. It requires years of training to understand the ramifications of his results. Caffarelli's ideas are deep and penetrating, and his combination of geometric insight and analytic tools is second to none. Research in mathematics can be a very lonely endeavor when you're facing a blank sheet of paper. Some mathematicians prefer to work alone, while others collaborate with colleagues, the young and the more experienced alike. With more than 130 collaborators, Luis Caffarelli has certainly shown the human side of modern research. Solving important and difficult problems by ingenious geometric insight and deep analytical tools, Caffarelli has left an enormous impact on mathematics and in the mathematical community. And in recognition of this great achievement, we are happy to award the 2023 Abel Prize to Luis Caffarelli. Thank you. So please, Luis, I now have the great honor to ask His Majesty King Harald to present the Abel Prize 2023 to Luis Caffarelli. Yeah.
Okay, thank you very much. Your Majesty, distinguished guests, and members of the Norwegian Academy of Science and Letters, I am honored and humbled to accept the Abel Prize today. This is a profound recognition, and I am very, very grateful to the Academy and the Abel Committee for selecting me as the recipient of such a wonderful award. I want to express my deep gratitude to the institutions that supported me through my career. Among them, el Colegio Nacional de Buenos Aires, la Universidad de Buenos Aires, the University of Minnesota, Courant Institute, the University of Chicago, the Institute for Advanced Study, and lastly, University of Texas at Austin, wherever Irene and I have lived residential the last 26 years. Thank you in particular to my collaborators, assistants, and friends through all these years, some of you sharing this event with me today. These institutions and their members, including faculty, graduate students, postdocs, and collaborators, can number me, provided the resources and opportunities to pursue our shared passions. Without their guidance, new ideas, and encouragement, I would not be standing here today. I am particularly grateful to Calixto Calderon, my PhD thesis advisor, who introduced me to the special function theory and the area of Abel summabilities, so meaning this for me at this time. I am also very grateful to Hans Levy, Louis Nirenberg, and Felix Brauder for their inspirations. Throughout my journey, I was inspired by the elegance of mathematics and its ability to uncover deep insights and solve complex problems across vast fields, and applying mathematics is a universal language with the power to transform the world. It is my hope that our collective efforts as mathematicians will continue to make a positive impact on society. I would also like to thank my family, in particular my sons, Alejandro, Nicolás, and Mauro, along with their spouses, Elise, Camille, and Camila. Our grandchildren, Isabella, look, they are very young children, right? Isabella, Luca, Javier, and Cecilia, and our niece, Lucia. And most important, to my wife, Irene, you have all been a source of encouragement and inspiration. Once again, thank you to the Norwegian Academy of Sciences and Letters for this incredible honor and for coordinated this event. I am excited to join the distinguished list of Abel Prize laureates who have contributed so much to mathematics. Thank you very much.
Many thanks to Arne Glorvigen for a moving performance of the Argentine tango El Marne, composed by Eduardo Arolas in 1919. And this is really a famous tango in Argentina. So now it's time to conclude this year's Abel Prize ceremony. Please welcome back Lise Ovreaas.
This is a great day in the field of mathematics and for the society at large. Today we honor great achievements. I would like to extend my warmest congratulations to Luis Caffarelli, Abel Laureate 2023. Your scientific contribution to the field of mathematics is of significant value for us. We really appreciate your presence today and are grateful for being able to celebrate together with you. I would also like to take the opportunity to thank everybody that has contributed to the continued success of the Abel Prize. The International Mathematical Union, the European Mathematical Society, the Heidel Laureate Forum, the Abel Committee, the Abel Board, the mathematical community which have contributed to establish a highly ranked international prize in mathematics. I would also like to thank the chair of the Abel Committee, Helge Holden, for your excellent work leading to the nomination process. In addition, my warmest thanks to Ingrid Glad, the chair of the Abel Board, for your esteemed work. Once again, congratulations to the Abel Laureate 2023, Luis Caffarelli.
Ladies and gentlemen, please rise for His Majesty Kong Harald.